Let us continue solving past exam papers on sequences and series. Don't forget to give a thumbs up for this video. The first question, the sum of the series, the summation from 1 to infinity, -1 the power of 2 the whole power of the whole over 2 square the whole the power of n, it says. Okay, let's write it first. Summation -1 the power of 2 the whole over 2 square the whole the power of n. N starts from 1 to infinity. What to do here? We can remove the square, you know. -1 square, it is the same as 1. Again here 2 square, it is the same as 4. So this summation can be written again 1 over 2 the power of n. N starts from 1 to infinity, not to the power of 4 the power of, I mean. Again, you know, 1 and 1 the power of n are the same, so we can write this summation as the summation 1 over 4 the whole the power of n. N starts from 1 to infinity. We can give the exponent n for both, for the numerator and for the denominator, because 1 and 1 the power of n are the same for any n. Now this is an infinite series starting from 1, so the common ratio obviously will be less than 1, so we can apply the formula g1 over 1 minus r. We can apply this formula. This time, what is g1? By substituting 1 in place of n, we can get it, that is 1 over 4, and the common ratio will be 1 over 4 the same. So this summation will be, according to the formula, it will be where is the formula? The formula is here. Actually, here is the formula. It says g1. What's g1? 1 over 4 the whole over 1 minus r. It says what's r again is 1 over 4. This is equal to 1 over 4 the whole over, when you subtract this one by crisscross, we'll get 3 over 4. So what to do here? 1 over 4 will be multiplied with 4 over 3, so the answer will be 1/3. That's going to be the answer for the first question. The second question, it says let Sn is equal to 4n square. What's given? Sum of n terms of the given sequence is 4n square. The formula already given. This means sum of n term. N term means maybe it depends on n. If n 10, sum of 10. If n is 100, sum of 100 it will be. So anyways, sum of n is given by this formula. What's n? It's an element of natural number. And then what is asked? What is the fourth term? The fourth term. So what is s of 1? First of all, s of 1, we need to substitute 1 in place of n, so it will be 4 times 1 square. That's going to be 4, but sum of 1 is the same as just a1. So this time we know the first term, a1. Here it is. Okay, what about s of 2? Let us substitute 2. 4 times 2 square, that's going to be 16. But what does this mean? This is the same as a1 plus a2. But we know a1. The a1 is already, we got it, 4. Therefore 16 is equal to 4 plus a2, so a2 is equal to 12. This is again a2, keep it. What about s3? Just to get to be sure whether it's arithmetic or sequence, arithmetic or geometric, let us see the pattern. Here the difference between them, you know, it is 8. Let us check for s3, you know, a2 and a1. What is the difference? It's 8. The difference, the common difference. So let us check by a3 and a2. If it gives us the same 8, we can conclude it is arithmetic. Sum of 3 means, let us insert 3 again in the formula. 4 times 3 square that's 9 times 4, that's 36, is the same as a1 plus a2 plus a3. But we know a1 plus a2, a1 plus a2, we got it already previously. Here it is. This means a1 plus a2, that is 16. 16 plus a3 is equal to 36. If you reshuffle, a3 will be, the 16 will go and subtract it. It's going to be 20. Okay. Again, when you see now the difference between a3 and a2, still it's 8, so the common difference will be 8, and the sequence is arithmetic. But what's asked? We are asked the fourth term, a4. a4 means obviously a3 plus the common difference, we can say. Or we can apply a4 is equal to a1. Let's write it properly. a1 plus 3d we can write. Since we know a1, we can apply because it's arithmetic. But since we know a3, a4 is equal to a3 plus the common difference. Again, the common difference, we got it already, 8. So a4 is equal to the third term, it is 20 plus 8. So a4 is equal to 28. That's going to be the answer for our second question. Okay, the third question, suppose that every year the amount of atoms of a certain radioactive substance is half of its previous year. If there were 6.4 times 10 raised to 8 atoms of the substance during the initial observation, how many atoms of the substance are present by the end of 10 years after initial observation, it says. Okay, what's given here? Initial observation, we can say initial, that is 6.4 times 10 the power of 8. This is the initial observation of the atoms at the beginning. But every year it is reduced by half. That means at the end of the first year it's going to be half of this, will be 3.2 times 10 the power of 8. You can divide by 2. When you make it 2 over 2 by 2, and this will be 3.2. The multiple times 10 the power of 2 will remain as it is. At the end of the second year, again half, it's going to be 1.6 times, when you divide it, 1.6 times 10 the power of 8, it goes. And then we are asked at the end of the 10th year, means we are asked G10. This one we can take it as G1. G1 means at the end of the first year. So we are asked G10. G10, the formula, it is G1 times R the power of 9. We can write it, because don't forget the formula, Gn is equal to G1 times R the power of n minus 1. This is the formula. From this we can recall G10 is equal to G1 times R raised to 9. Okay, what is G1? The G1 is, it's here at the end of the first year. And what about the common ratio? The common ratio we can divide. When you divide, you will get 1.6 times 10 the power of 8 the whole over 3.2 times 10 the power of 8. This is G1, I mean G2, this is G1. It's geometric because it's reducing by half, means it's just half actually, because it's reducing by half. So if you divide, you'll get 1 over 2. 1 over 2 means to the power of negative 1. Or you can take it as it is 1 over 2. But 1 over 2, it is the same as to the power of negative 1. For calculation purpose, we can use it in this way. And what's G1? 3.2 times 10 the power of 8 times what is R to the power of negative 1, the whole the power of 9. Okay. Now let us try to simplify. 3.2 is the same as 32 over 10. We can write it in this way. Multiply with 10 the power of 8 times 2 the power of negative 9. Now here is 10. Here how many tens are there? 8 tens. 10 times 10 times, 8 tens are multiplied. 10 the power of 8 means multiplying the 10 8 times. So we can cut 1 10, and then this exponent will be 7. Then what remain here? 32, which is 2 the power of 5 times 10 the power of 7 times 2 the power of negative 9 remain. What did I do? 32, we can express it as 2 the power of 5 4, because 32 is the same as 2 times 2 times 2. You know, we'll multiply 2 5 times. Now try to observe this. They are having the same base and they are exponential with base 2, so we can subtract or we can add the exponent. 5 plus negative 9 will be negative 4. So we can write finally the answer, which will be 2 the power of negative 4 times 10 the power of 7. This much amount of atoms left at the end of the 10th year. That's the second question. Okay, the next question. What is given? AN is an arithmetic sequence. Given A1 is equal to 5 and A5 is equal to 21. But what means A5? A5 is the same as A1 plus 4D, which is 21. But A1 we know it's given, here it is, that is 5, we can bring it. So 5 plus 4D is equal to 21. Then shift the 5 to the other side, so 4D is equal to 16. You can divide by 4 both sides and get D. D is equal to 4. These are the main or the critical points, A1 and the common difference in case of arithmetic sequence. Then whatever asked, it will be easier. We are asked the sum of 30 terms. So sum of 13, let's state the formula first. Sum of 30 is equal to 30 over 2 bracket A1 plus A30. This is the same as this is 15 in bracket. The A1 is 5 plus A30. What is A30? Again, we can get it easily. A30 is equal to A1 plus 29D, which is 5 plus 29 times, what's the common difference? That's 4. We got it. 5 plus 36, we have 3, 11, so 121. Then 15 in bracket 5 plus 121, because A30 we got it already. So 15 multiplied with 126, then when you multiply, it's going to be 1890 will be the final answer. So we are asked the sum of the partial sum of 30 terms, which is 1880. Let us go to the next question. The next question, it is asking us the sum of 2-digit natural numbers that are multiples of 4. What are 2-digit numbers? They start from 10, then 11, then 12, then 13, 14, 15, 16. It goes until what? Until 99. These are the whole 2-digit numbers. But it doesn't say only 2-digit numbers. It says 2-digit natural numbers that are multiples of 4. Okay, so which numbers are multiples of 4? Let's start at 12. 10 and 11 are not divisible by 4, and 13, 14, 15 also not, and again 16 comes, and after 16 what will come? 20 comes. You know, it goes by 4 gap. So we can take this one as A1, and the common difference we can take it as 4. What is the last term which is divisible by 4? Check by dividing. 99 divided by 4. This is like general process. When you divide, you know, 2 times 8, remainder 1, again 9 times, it's going to be 4 times 16. What's the remainder? 3. So you need to subtract from 99 3, so it will be 96. That's going to be the last term which is divisible by 4. What did I do? I divide 99 by 4, and then I'll try to observe the remainder. The remainder is 3. Since 99 is the last term, we cannot proceed. If we can continue, we can add 1 to know the next term. But this is the last term because we are talking about 2-digit numbers. We cannot go beyond 99. So we have to think of before 99. What is a number that's divisible by 4? Necessarily, we have to subtract this 3 and we'll get it. That is the last term. Okay. So the last term that's going to be divisible by 4 is 96. So we are asked the sum. So sum of n is equal to n over 2 in bracket a1 plus an. We know a1, that is 12. We know an also, the last term, that's 96. But we don't know how many terms are there. How many terms means how many numbers are there, two-digit numbers which are divisible by 4, how many they are totally. We can get that because we can apply an is equal to a1 plus n minus 1 times d. We know the an, the last term, that's 96, is equal to the first term is 12 plus n minus 1 times 4. You know the common difference. So let's find how many multiples of 4 are there totally. So 96 is equal to 12 plus 4n minus 4. I can multiply. So 96 is equal to 12. 12 minus 4 is 8. I can say here 8 plus 4n. So if I bring the 8 here, it's going to be 88 is equal to 4n. If I divide by 4, n is equal to 22. What does this 22 means? The number of multiples of 4 which are found between 12 and 96. Like in another way, the number of multiples of 4, two-digit numbers which are multiple of 4, are 22. So that the sum of these 22 terms will be 22 over 2 in bracket. The first term is 12 plus 96, the last term. So if you divide, this will be 11. So when you add it, it will be 108. So if you multiply by 11, it's going to be 1188 when you multiply 11 by 108. So this is our 5th question. Let us continue to the next one. The next question, it says if 3a, b and 17 are successive terms of arithmetic progression. That means if it is arithmetic, we can take this one as a1, this one as a2, this one as a3, and this one as a4. What's given? a1 and a4. So to get the common difference, we can take a4 is equal to a1 plus 3d. Because I know a4 and I know a1, we can easily find the common difference, and then we can get the middle terms by adding those common differences. So the fourth term, it's given, which is 27. This is 27. So I can write here 27 is equal to the a1 is 3 plus 3d. If I shift it, 24 is equal to 3d main. If I bring the 3 to the left side, if I divide by 3 both sides, the common difference will be 8. Now each term will be 8 plus the previous term. So a is equal to, a means the second term, the previous term is 3 plus 8, which is 11. And what about b? B is equal to the previous term, a plus 8 again, because it's arithmetic. So b is equal to 11 plus 8. So b is equal to 19. So we are asked to find a and b, that's 11 and 19. The next question, consider the sequence an for n greater or equal to 1, where the first term is given, a1 is equal to 2, and an plus 1 is equal to an plus 4, it's given again for n greater or equal to 1. Then the sum of a2 plus a4 plus a5 plus until a40 we are asked. Okay, we know a1. What about a2? How to get it a2? Let us insert 1 here, and here also 1. If you insert, because for n, it says for n greater or equal to 1 means we can insert in place of 1 any numbers like n or 1 or 2, 3, 4. So let us try to insert numbers from 1. Let's insert here in place of n. When you insert 1, it will be a2 this one, because when you insert 1, 1 plus 1 will be a2, which is equal to a1 plus 4, because when I insert 1 here and here, when we take 1 in place of n, we have to substitute every places of n. So here 1 plus 1 will be a2. So what's a1? That's 2. So a2 is equal to 2 plus 4. So a2 is equal to 6. Okay, a2 is equal to 6. Okay, we got it. A2 also, that is 6. What if we take in place of n the second 2? Let us take 2 again. If we insert 2 here and here, what will happen? a3 is equal to a2 plus 4. Okay, what is a2? 6 plus 4, that is 10. So A3 is equal to 10 again. Okay, let us stop and see now here. When you try to see here, the difference between them is 4. Here also it's 4. It's increasing by 4. Its common difference is 4. It's arithmetic. Okay, A1 is equal to 2 and the common difference is 4. What is asked? Sum of 40, but starting from 2 it says. So first of all, let's find sum of 40. Sum of 40 means 40 over 2 in bracket A1 plus A40. Okay, we know A1, but let's get A40. A40 is equal to, let's do it by another color. A40 is equal to A1 plus 39D. The A1 is 2 plus 39 times 4, because the common difference is 4. That's going to be, so A40 will be 158. So now let us continue. Sum of the 40 terms is equal to, you can simplify this, it's going to be 20, then in bracket 2 plus 158. So this will be 3200. You can add the 2 and then multiply by 20. But this is sum of 40. Sum of 40 means it's the same as A1 plus A2 plus, it goes until A40. But we are asked from A2, so we need to subtract the A1 from here. The A1 is just 2, so A2 plus A3 plus until A40 is equal to the 3200 minus 2, which is 3198. That's going to be the answer. This is the answer for sum of the terms starting from 2 until 40. Because when we say from 2 to 40, we have to remove the first term. The first term is already given, that is. So this is somehow trick. What makes it trick? After all the process, we need to think of which terms has to be avoided. The first term only this time. Maybe sometimes you might be asked from the third or from the fourth term. So we need to think that. This is our 7th question. Let's go to the next one again. The next question, it says, if the arithmetic mean of two numbers A and B, where A and B are both greater than 0, is 5 times the geometric mean. First of all, we have two numbers A and B. So these two numbers A and B, they have arithmetic mean and geometric mean. So what is arithmetic mean between two numbers A and B? Obviously it is the sum of the numbers divided by 2. We know this. What about geometric mean? The geometric mean is the square root of the product. These are the two. But what does he say now? Let us try to interpret. We know arithmetic mean, we know geometric mean for two numbers A and B. These are the arithmetic and the geometric mean. But the question is, if the arithmetic mean of two numbers A and B is 5 times the geometric mean, that means this is the same as A plus B over 2 is equal to 5 times the square root of AB. This is the first and the beginning point. The arithmetic mean, okay, is equal to 5 times the geometric mean, it says. So this time we can multiply by 2 both sides, and we can remove this denominator 2 by multiplying both sides by 2. What remain? A plus B remain left side, the other side 10 times square root of AB remain. When you multiply by 2 both sides, this one multiply by 2, this also multiply by 2, 2 times 5, 10. Okay, let us square it. When you square, we will have A plus B the whole square is equal to, it's going to be 100 AB. But what means A plus B the whole square? It's A square plus 2AB plus B square. This is equal to 100 AB. Here we need to be systematic. What is asked? We are asked A plus B over A minus B. We can find A plus B from what we have here. From here we can find A plus B easily, because A plus B square, already we said 100 AB. We got it from the previous. But now let's try to focus how to get A minus B. To get A minus B, let us subtract minus 4AB from both sides. When you subtract, this plus 2AB will be minus 2AB. Then we can express A minus B the whole square by the difference square. what I'm saying, a square plus 2ab minus 4ab plus b square is equal to 100. This is 100ab. Let's write it from the above. This is okay. Let us use the same color. This means 100ab. So what we'll have, 100ab minus 4ab. I did nothing, just I subtract minus 4ab from the left side and from the right side. Why that? Because when we subtract now 2ab minus 4ab remain a square minus 2ab plus b square remain the left side. The other side, it's going to be 96 ab, because 100 minus 4. Then what's the objective of expressing? Okay, it was a square plus 2ab, now it become a square minus 2, because a square minus 2ab plus b square, it is the same as the difference square, a minus b whole square. This is equal to 96 ab. Okay, now again I got it, the a minus b, I got it, here it is. So I have both of them. Our objective is to get a plus b and a minus b. So if I put both sides in the square root, let us use our space. Let us remove this part since I already explained it. Now I can write a plus b square over a minus b square, because both of them I have. A plus b the whole square, it's 100ab over 96ab. Now we can cut ab and ab, and we can simplify if possible. This by 4 it will be 25, this by 4 it's going to be 224, so we can keep it as it is. Then the left hand side, it can be written as a plus b the whole over a minus b the whole square. That is 25 over 24. But we don't need the square, we need to remove. So to remove the square, I can put both sides in the square root. Then a plus b over a minus b will be the square root of 25 over 24. Square root of 25 is 5, and the denominator part, square root of 24, is the same as 6 times 4. So it will be 2 radical 6. We can write, because the 4 is perfect square number. Therefore, we can rationalize by 6. When you multiply by 6, 5 root 6 the whole over 2 times 6 will be 12. So either this one or this one can be the answer. Anyways, here it looks somehow simpler question. Of course it is, but somehow longer process. These are some of the questions that I prepared for today. I hope we'll continue with additional questions. Don't forget to subscribe, like, and comment. Thank you.